Alright guys, so this is the last video for right triangle trig before we connect this into something called the unit circle, which will be what we learn next week. So you might remember this from geometry, but we are going to review special right triangles. And what these are just regular right triangles. I can tell they're right triangles by the 90 degrees here. And let's just focus in on one of them. Let's focus in on the 30, 60, 90 triangle. We call it that because one of the acute angles is 30 and the other is 60. And instead of doing SOHCAHTOA, for a 30, 60, 90 triangle, you're going to get the same thing every time in this pattern. And so we could just skip doing SOHCAHTOA and use this diagram as a shortcut to help us, and I'll explain that shortcut more in a second. But that's what it is. It's just a shortcut to SOHCAHTOA with exact answers. So notice I'm getting exact answers and not decimals. That's why you have root 3 in your answer. Okay, and then let's look at the 45, 45, 90. That's just a right triangle, again, with the 90 degree, except for the two acute angles are the exact same, which is what forces two of the legs to be the exact same. And again, instead of doing SOHCAHTOA, I can get an exact answer, and so I can skip SOHCAHTOA and get an even better answer than a decimal. So this is more advantageous than doing SOHCAHTOA because you get exact answers. The only job that we have to do is to figure out these patterns and learn how to apply them. Okay, so let me explain the patterns because this is the only thing this lesson on is you understanding these patterns and being able to apply it to different examples. So if I look at the 30, 60, 90 triangle, notice that there's a shorter leg and a longer leg. And if it ever is hard for you to tell which one's the short leg and which one's the long leg, the short leg will always be across from the smallest angle, which is 30 degrees. And the leg will always be across from the 60-degree angle, the long leg. And the hypotenuse, which is the longest, will be across from the biggest angle, which is 90. So we always want to start with 30, 60, 90 triangles with the short leg, because notice whatever this value is, A, we're going to use it here and here. Both of the other ones involve using A. Or you might see it as X, or you might see it as short leg, like written out in words. Whatever the short leg is, whatever letter we use for it, you use that letter in both of the other ones. So it's important that you get the short leg first. So let me give you a quick example. If the short leg is 5, then it says the long leg over here is square root 3 times the short leg. So it would just be short leg times square root 3, and that's your answer. And the hypotenuse, it says it's 2 times A, so it's 2 times the short leg. So what's 2 times 5? That's 10. And automatically, that quickly, you know all three side lengths without doing SOHCAHTOA. That's how easy it is. Okay, let me give you a backwards example of that. What if we didn't know the short leg first? What if we knew the hypotenuse? What if I knew that the hypotenuse was, let's say, 40? Well, since that's double the short leg, I know the short leg must be 20. So I can go backwards. If I start here, I can just divide by 2 to get the short leg. Now that I know the short leg, getting the long leg is really easy because it's always square root 3 times short leg. So it's going to be short leg times square root 3. So it's really easy to get all three side lengths once you know the shortcut, and you can skip doing SOHCAHTOA. Alright, so now let's talk about the 45, 45, 90 triangle. This rule is even easier because since both of these angles are the same, that forces the sides across from them to be the same. So 45, 45, 90 triangles are isosceles right triangles where both the legs are the same side lengths. So notice whatever they are. Let's do the same example of 5. If this one's 5, I automatically know this one must be 5. And then my hypotenuse, it just says square root 2 times the leg. So 5 times square root 2, and you're done. Okay? Alright, so that's an easy example with 45, 45, 90. Let me show you one more. What if we go backwards and we had started with the hypotenuse? What if I knew the hypotenuse had a length of, let's say, 13 times square root 2? Well, then that just shows me, since the hypotenuse is square root 2 times A, and here I have square root 2 times a number, this number must be A. So then I know this is 13 and this is 13. So it's pretty easy. You can skip SOHCAHTOA, and again, it's not that skipping SOHCAHTOA is like an amazing feature. The amazing feature about special right triangles is that you get exact answers. You have all these roots in your answer instead of complicated decimals. And this is the one main important thing, special right triangles, of any of the right triangle work we've been doing, that's going to carry on into the next section. So really important to get this video down. All right, so let's do some examples. In this triangle, now I did put the exact same picture in every slide. That way you can look back up there to remind yourself of the rules. In this picture, we have a 30, 60, 90 triangle. I can tell that by the markings. And so I'm going to focus in on this rule right here. Now, luckily, I have the short leg. The short leg's already given to me. That was a terrible straight line. Let me do that again. The short leg is the one already given to me. It's obvious to me in this picture that that's the short leg, but if that wasn't obvious to you, that this is clearly shorter than the other ones, you can also notice it's the one right across from the 30-degree angle. Since the 30-degree angle is the smallest in the picture, then that side across from it must be the smallest. All right, and what does my rule say? So let's look back up at this box. The rule says once you have the short leg, all you do is double it 2 times a to get the hypotenuse. So I can get x by just doubling it. So what's 2 times 1/2? It's 1. So that shows me that my hypotenuse is 1, and I'm done. I didn't have to do SOHCAHTOA. All right, and now let's get the long leg. The long leg is just square root of 3 times whatever the short leg is. So take the short leg and times it by the square root of 3, and you're done. And I've solved that example, and I can move on. Again, the really cool thing is that this is all in exact form, and so I don't have to worry about any decimals. I do want to point out another way of writing this would be square root 3 divided by 2, instead of saying 1/2 times square root 3. This is actually how you'll see it. All right, so let's do an example with a 45, 45, 90 triangle. Since I see it's a 45, 45, 90 triangle, I'm going to use this rule over here. And the rule here is that the legs will always be the same length because these angles are the exact same. So that forces the legs across from them to be the same. So if one of them is 8, that means the other one must be 8. And I'm already done with that part of it. Again, if I had done SOHCAHTOA, I would have gotten the exact same thing. All right, so now all I have to do is the hypotenuse. What does the hypotenuse say? It says it's square root 2 times the leg. So I'm going to take the leg and times it by square root 2, and there's my hypotenuse. And I'm done. I've solved for this triangle. All right, so why don't you pause and see if you can get these 2 examples. And just for your convenience, I did put these rules over here in the corner, so that way you don't have to flip back and try and find those. All right, so let's check it over together. This first example, you have a 45, 45, 90 triangle. Even though it didn't tell you this is 45 degrees, you know it's 45 degrees because there's only 180 degrees in a triangle. So if you were to figure out what that angle is, you would be doing 180 minus 90 for this degree right here, minus 45 for this degree right here. And when you do that, you get a leftover of 45. So I know that this is a 45, 45, 90 triangle. Okay, so with that, that tells me that the legs are the same. So I'm going to highlight the legs. These 2 have to be the same because that's what this rule says over here. So if this one's 14, that means the other one has to be 14. And now all that's left to do is figure out the hypotenuse. The hypotenuse is always square root 2 times the leg. So I'm going to do the leg times by square root 2, and I'm done. So first example, nice and easy, using my 45, 45, 90 rule. Let's look at the second one. There's a little bit more work. It's a little bit harder. I'll walk you guys through this one. So this is a 30, 60, 90 triangle, so I'm going to be using this rule right here. The only thing that's kind of difficult about this is I have the long leg. So this is kind of the hardest type of problem because that corresponds to this side right here, square root 3 times the short leg. So I always want to start with the short leg, but unfortunately I couldn't in this situation. So what we're going to do is just solve for it. If 12 is the long leg and it equals square root 3 times a, or short leg, or x, whatever you want to call it, then just set that up as an equation. 12 equals square root 3 times a. And then I could just solve for a. So let's do that. Let's divide both sides by square root 3. And so let me bring it over here. I have a equals 12 divided by square root 3. The only issue again is that you have a root in the denominator, so I'm going to rationalize. Doing that, the denominator would become 3, so let me erase that and write 3. And then, the only other one more thing I could do is 12 divided by 3 is 4. So why don't I just erase that and write 4. You could write 4 over 1 if that helps you to see it as a fraction, but we know that that's just the same thing as 4. Okay, so my short leg is 4 times square root 3. And again, I got that just because I had the long leg, and I set that equal to its formula over there. Now that you have the short leg, we can really easily solve for the hypotenuse. What's my rule for the hypotenuse? It's that it's double 2 times a. So it's double the short leg. What was my short leg? This. So I need to take that whole thing and just times it by 2. What parts can you multiply together? The regular numbers. 4 times 2 is 8, so this will be equal to 8 square root 3. Okay, if you kind of just want to check and make sure that you got it right, like if we had started knowing this value right here, knowing the short leg, then we could kind of go back and check and say, all right, in my rule over here, the long leg is square root 3 times the short leg. So why don't we check it? Why don't I take the short leg and times that by an extra square root 3, and let's see what we get. Well, square root 3 times square root 3 is just 3, and now I have to times it by this extra 4. What's 4 times 3? 12, which is exactly what this says. So I know that I have the right values. Okay, and that's it, you guys. If you understand 30, 60, 90 rules and 45, 45, 90 rules, then you are all good to go. I put this note on here just to remind you that this is going to be how we start studying the unit circle. So getting special right triangles down is a really important skill to have moving forward. Have a good day, you guys.